Hey guys, so picking up from the last one, uh, we're gonna go into our just the lab lecture part, and then I will leave it to Evan to continue on with my on-campus students. So again, um, like I said in the lecture side of it, we are continuing. We are going to be trying to give you guys as much field work or as much of hands-on experience as possible as it can be with this course. So starting off, Tuesday, we're gonna have Tuesday the what is that? April Fool's Day, or sorry, not yeah, April Fool's Day. Yep. So April 1st, um, we will have our first lab, and that's going to be differential leveling. And again, I believe you guys are, familiar with it, doing it in the practicum, doing it week 4 here and there. But the importance is to keep continuing, right? To keep practicing and practicing. That way you making improvements on this. So let's just go over some review stuff, and then from there, we'll review for a second, and then after that, we'll go into the actual lab. And then after that, we'll go into just kind of references that you can use for the lab. All right. So, number one, let me pull up um, that handout, that book, that GME 161 lab manual, just to give you guys a reference there. That's pretty useful. Let's see here. Labs, one, leveling. See. I'm gonna hang on. I'm gonna pull these guys up real quick. I want these guys in there. This one in there as well, just in case. Procedures. I'm gonna have that one. Guys, all just in case. So have everything. I believe I had something. I have that. There it is. There's that guy, and I gotta scroll down real quick to find, because I'm skipping. Obviously this is 161, so we're skipping over. So I wanted to show you this guy, this image here in a second. We'll step to that in a second. And then the other thing I want to pull up is from last term, was the other notes that were available. Oh, that's the traversal calculations. Where is the? Oh, here we go. Perfect. Adjusted. That's the one I'm looking for. So, all right, let's go back through. All right, so plane surveying, 2, and then we're going to do level looping. So first things first, I'll pull up the guy. So again, lab exercise 1, differential level looping. The two objectives are learn how to test the calibration of a mathematic level from the PEG test. So again, I'm going to give you guys the PEG test to do, and then we're going to establish elevations on specific points by method of differential leveling. So discussion, the PEG test is quick, field expedient procedure to determine if the level is an adjustment. The PEG test should be performed on equipment regularly to ensure that the instrument is not drifting out of calibration or anytime the instrument has been subject to a severe shock. Differential leveling is the technique by which the elevations are determined, or more precisely, elevation differences are determined for a station or stations. The loop begins at a known point, in our case, Ager, typically a benchmark, runs to points of unknown elevation. Intermediate points, known as turning points, are established along the leveling route in order to carry elevations to the points of unknown elevations. A differential leveling loop ends on the starting benchmark, thereby providing a check on the work. So again, you are transferring elevations starting with your known elevation to every single point that you are going to, whether it's a turning point or a station or another, trying to establish another benchmark. Okay. So let's go back through kind of the small things that we need to remember. Let's go here. Um, let's go here. So again, remember when you're reading that rod level, and let me try to zoom in on this guy and get rid of that, right? you have your foot marker, and then you have your hundredths. And you just got to remember that this right here is 6-0, the top, right? Because top is even, bottom is odd. So that's 601, 602, 603, 604, right? And again, the reason we wave the rod, it waves back and forth. Let me put myself on video here. Or I guess I don't need to. The reason we wave that rod back and forth when we're taking that reading is because it's going to show you the crosshairs are going to hit the lowest point, right? When you're looking through that main crosshair, it's going to hit you that lowest point, and that'll be your rod reading that you need to get. Let's see. So again, the first thing that we're going to do is that peg test, right? So when we do that peg test, we're going to need the automatic level rod. Well, yeah, level rod, and the tripod. You'll need a calculator so that way you can do your stuff on the ground. And then if you are not using concrete or like concrete sidewalk or some type of asphalt or some type of permanent location, you need to use turning point spikes like a railroad spike because we will not be using natural ground. That's one of the rule number ones of differential leveling. We do not use natural ground, right? We have to use something permanent and solid. Natural ground, via being the season, can freeze and have, it can do that freeze thaw where it can kind of elevation can go up or down with the freezing temperature. If it's super muddy, right? If it's raining a lot, it's a lot of wet out there, it can be really muddy and your rod can sink, right? So we need something that's not going to change in elevation, all right, in that part. So again, task number 1, perform the peg test to verify the calibration of the assigned level. And task number 2, perform a differential level to determine the elevation of the unknown points. So again, the automatic peg test, you're going to set 2 hubs apart, or again, you can use the campus. Let me pull up and let me see here. I'll move my guy there. Let's go to campus here and pull up the aerial. So if you were in my 161 lab, right, there's this flat piece right here on the sidewalk, and it's going to be 200 feet apart. So you probably need to, if you're going to be on this side, it would probably be over here somewhere, right, when you're reading this, and then you can be over here to be 200, and then the I-man is 100 feet in between. All right. Again, there's this piece over here, pretty flat through here. You can use this north-south run. You guys can come all the way over here to this south side of Cornet, use this big flat piece over here, right? You guys can do that, or like we did in the actual exercise, we can set the 2 hubs apart, right, to approximately 200 feet. And again, remember your pacing, right? You guys, week 1, 161, we did pacing, so you guys can do it via pacing, or you guys can go out there if you want to with a tape measure, with one of those big tape measures, and pull 200 feet both sides. So again, you will you got to note that points A and B are fixed points on the ground, not natural ground, right? Concrete, hub, railroad spike, right? Points A and B should be approximately 200 feet apart, and then points C and D represent the instrument setup. So again, C is your first setup, right? You're going to be 100 feet here and 100 feet here, right? And then you're going to take your measurements to A, take your measurements to B, and then once you get those measurements, you're going to move your instrument closer to B, and then first take your measurement to A, and then take your measurement to B, right? That's what these whole 1, 2, 3, 4, 5 are there. And then you're going to take your deltas, right? So again, if you get a reading here of like 6.6, and your next reading here was 5.4, right? Your delta there is 1.2, right? That's your delta between the two. And then you pick up your instrument, you take a station, you take your reading, and again, you get 6.45, right? And you take this reading and you get, 5.23 or 229, I guess. I don't know, something like, or 30, whatever it is, So whatever that's going to be. Let's just say, you know, so let's say you get 5.3 here, right? And you get a rod reading here of 1.1, and you take your deltas and you get 0.1, right? That is nowhere close, right? That 0.1, we need to be 0.01 within 200s, right? What we're looking for, make sure we're within calibration, is 0.2 hundredths of a foot, right? That's what we need to be. Um, so we should, but I mean, I say here with 100th, but 200th would be tolerable for this portion. All right. So again, make sure that your overall delta is within 200ths. All right. So task 2, determining elevations by differential leveling. So again, we are beginning at an identified benchmark, and we are going to begin at Ager. Okay. So remember, you don't have, we're not going to use these sheets right here, right? You have Ager, you're given Ager, and you're given the elevation. The rest is up to you to use your field book, right? Let's see where to go. Come on. 162. My guy here. No, yeah, election. It's underlap. Sorry. I got out of it earlier than I shouldn't have. So again, you need to set up your index. You need to set up your field book, right? And you need the first two things are going to, or your first line is going to be here. Your next line is going to be Ager, and it's going to be that 420, 43, 25, 50, not 51, right? You already had a mistake there on that line. So again, you're going to start at Ager. You're going to run through the locations. And this time we are giving you the locations, but you are using what we have, the network control campus, and we have we have benchmarks out there, part of the network control campus that you are going to go find and use. So again, steps 1 through 6 are just like 161. You're going to run through everything. Again, you're not using railroad spikes for turning points. You are not using natural ground for turning points. You are using, if you can't find something like a curb or a sidewalk or pavement, you are using a railroad spike or a hub, right? You are setting that in the ground. And again, you should be with your closure should be within class 3. After you determine all that, you are going to run through an adjustment, right? So right here, let's focus on right here, and then we'll focus on the adjustment part. So for your differential level run, you will hold NGS station Ager as your benchmark. You will run a level loop to determine the elevations of monuments A Walker, Ortec, Melva, and Duryea. Then return back to station Ager. See the OIT network book for reference. Record your level loop data in the table below. Well, actually, let me change that. Record it in your field book. The elevation for the steel rod is 43.2550 in North American vertical datum of 1988. You're going to calculate the raw and adjusted elevations. Your raw, I would calculate as you go in the field. Your adjusted elevations are once you meet that class 3, then you do your adjusted elevations, and that's something you can do inside or when you're done with your fieldwork part from your observations, right? So, and then we have some questions. And again, similar to 161, we have some of those questions just to see if you guys learned anything, if you guys did anything different from that first lab. So now going back to right here, the monuments. Let's go through this network control, and I believe that should be right there. Campus control redacted. That's that guy. All right. That is there available for everybody. So this was published in 2011. I believe there's been, some other, destroyed. This median 2 needs to be updated. That has been destroyed when they redid the west side of the industrial way there, that new road that they did by the soccer field. That was destroyed with it. We tied that in, but we can replace that as well. But anyways, so we have, let me zoom in here. As you can see, Ager, as you're starting, you have Walker, you have Ortec, Melva, Duryea, and A back to Ager. All right. So again, don't feel overwhelmed because you have again Tuesday and Thursday to get this lab completed, right? The fieldwork portion of it. The office side of it, again, you probably can you have the weekend as well to get that done because this won't be due to the following week, right? So it probably won't be due to the following Friday after this is all done. So again, we're gonna go Ager, Walker, Ortec, Melva, and Duryea. And if you scroll through there, Ager, it gives you lat longs, it gives you descriptions of everything, right? What's looking like. And again, you open it up. What's intervisible? Well, Duryea and Walker are intervisible. And again, there's a reference there. And again, that was pretty easy for you guys. Well, then what about Walker? All right, let's go find Walker. And again, if we go back to the table of contents, Walker's on page 40. So let's go back to page 40, or let's go down to page 40. No, sorry, that's so 43. Okay, so it's just because of the difference between PDF and the actual table of contents. So Monument Walker, it's the 2-inch aluminum cap, right? It looks like it was set. So there was a 5/8 inch diameter rebar firmly set 2 inches below the surface, and an aluminum cap, right? So from which, and again, here's the sketch. We have the 1.5 diameter deciduous tree. We have a lamppost. We have the geothermal. There's the fountain. Okay. There is a deciduous tree that bears 2 degrees, 33.4 feet from it. There is a 15-foot lamppost. Yeah. Okay. That's the height of the lamppost. And it bears south 46 degrees, 45.1 feet. So that is from the monument itself, right? This is southeast this way. Same thing, northeast this way. So if you start at the tree and go this way, it's just the opposite bearings of that, right? And then we have the northwest corner of the concrete geothermal, this guy here, that bears south 50 degrees, 61 feet, 61.3 feet. Okay. And then corner is located in the grass east of the southeast corner of Owens. All right. And we look at it via photo wise. This is looking north, right? There's that deciduous tree. It's buried there. There's looking at College Union. You can still see the monument there. There is the geothermal kind of in line with that Easter wall there. And then there is Owens right here. And then you can see the sidewalk. So there's where it's buried. All right. So there is our first benchmark to hit. The next one to hit is Ortec or Melva. Does it have to be in that certain order? Just one of the next two. So let's go back to that page. Where was I? There we go. And we're gonna let's go to Melva there real quick. 24. So I'm thinking it's gonna be 27. There it is. All right. So Melva, again, another 5/8 diameter rebar set firmly 2 inches below the surface of the ground, an aluminum cap, marked Melva 2006, from which we have a sidewalk, bears 18 north 18 east, 21.8 feet. Another sidewalk, north 32 west, 23.1. Corner and median says the corner is in the middle of grassy median of Owens Hall. So we have grass, we have the sidewalk here, 2 sidewalks, another little corner there. There's the fountain. So there's looks like that's looking north there. There's the gymnasium, LRC is here. So we have a sidewalk here. We have a sidewalk here. There's Melva looking east of the College Union. There's those walkways there. Looking south to the geothermal line, kind of somewhat more closer to that easterly path of that sidewalk that runs north-south. And then looking at the Owens there, it's right, kind of splits the middle of that hallway, the hallway there. Okay. Melva there. All right. Back to the table of contents. What is Ortec? It takes on, looks like 33. So Ortec, that one is a again another 5/8 rebar with a 4-inch aluminum cap, and it is stamped Ortec 2006. So there's a 4-inch. Look for a 4-inch, guys. So the sidewalk, and that is our reference, is intersection bears 6 degrees northeast, 33.8 feet. All right, so we have Ortec here on the grassy side. And then we have the southwest flower bed. Do we have a flower bed? I don't know if the flower bed's still going to be there, but that's going to be a tricky one. And then we have the corner is located 2.9 feet west of the sidewalk in the grassy medium of the West College building. So, okay. So let's look at these sketches here. So here is the top of the landing, right? We have the gymnasium. There's the west. Oh, there's the flower bed right there in front, right there. And again, 2.9 feet off that sidewalk edge there. And then we have another view going that way. All right. So there is Ortec. And then our last guy, we want to go to Duryea, and that's going to be on page 13. And again, another 5/8 inch diameter rebar firmly set 3 inches below surface ground with an aluminum cap stamped Duryea 2011. So we have, looks like a stormwater manhole that is they're using as a reference. So we have Duryea here. There's the stormwater manhole. We have the center of a red fire sprinkler valve, and that's southwest. So the sprinkler valve on the other side of the sidewalk. So this is Cornet here. This is the LRC. We got the sidewalk, we got a parking lot, and then we just have I think there's that new big structure, that civil structure that's right here, right? So let's look at it here. This looking north, right? This is that little parking lot. It's got that big structure now. Again, this was back in 2011. None of this was there. There's that new structure, that mechanical structure. This is the LRC looking east. Looking at Cornet, the old version of Cornet when it was ugly maroon color, or not maroon, salmon color thing, and looking south there. All right. So again, those are your 3 monuments to go search for. All right. So those are the 3 those are the other monuments that I want to be tied. And again, so we'll start on Ager. We're going to go to Walker, Ortec, Melva, Duryea, and then we're going to close back in on Ager. And again, we want to meet that class 3. Okay. So let's say we get that class 3, we're all good there. Now we have to run through the adjusted elevations, right? So quick example that we have for this one is, so let's say we run through it, you go through and you say, all right, it was 87.22 and I ended at 87.27. Well, let me double check everything. I'll add up all my foresights. I'll add up all my backsides, and the deltas of my foresight and backside should be the same as my starting and closing elevation, right? So we did that. We get that 500ths of 500ths. It's like, okay, so we are checking, right? My deltas between my foresights and backsides and my starting and ending are exactly the same at 500ths. So now what do I have to do to make the adjusted elevation work? So what I got to do is take that 500ths divided by the number of setups. And how do I determine that? I can just count the number of HIs, right? I have 1, 2, 3, 4, 5, 6 HIs, right? That's the height of instrument. Divide that, and I have to now use 8 thousandths, right? 8 thousandths of a foot per setup. All right. So that's what I have to do, because, so again, the adding or subtracting part depends if you closed high or low, right? So here we closed at 87.27. That's 500ths higher. So now we have to subtract from every single one of these elevations to get the adjusted elevation correct and end at 87.22, right? So now we take our 8 thousandths, and again, error is high, so we subtract adjustment, and we're going to multiply error correction at each setup by the number of setups to elevation being adjusted. So at station or at setup 1, we're going to go our 88.99 minus that 8 thousandths times 1, and it's going to still give us that 88.98, right? So that is going to be the same. Or sorry, that is going to be just a 100th difference. That's all that is. The next one is 97.03, and that's going to be subtracted by that 8 thousandths of a foot times the setup number 2, and that's going to give us 97.01 right there, right? And now you can see that there's a difference there. And you can continue on all the way until you get to here, and that's how you're going to get your adjusted elevation. All right. So perfect. All right. Let's see. Let's go through again. We went through the setups, went through the campus. We went through all the good stuff of the peg test. Let me make sure I covered everything before I let you guys go. So again, the field laboratory procedure. Just let's go back to the very basics of this stuff, right? Let's just go back to just kind of doing the right stuff, right? Making sure we're doing things the right way. So the goal of GME 162 labs is to expose the students to the logistics of field surveying, operating survey various instruments, reducing field data, and meeting specifications. Most students have limited industry experience. I mean, this is your first year, most likely in the program, if you're on campus. So it's probably a lot of you, it's just kind of your first time getting hands-on all these instruments and procedures. So I expected there will be a learning curve, right? Don't hesitate to ask questions. If there's a crew member that makes mistakes, that is expected, right? And that it happened in 161, wasn't the end of the world. We just corrected it, and that's what it needs to be. In a professional work setting, it is important to admit mistakes and the collaboratory deal with them in most efficient manners. The old saying is the person who never makes a mistake doesn't work here either. Neither does the person who repeats mistakes, right? So again, we have to learn from our mistakes. We are allowed to make mistakes, of course, but if we don't learn from the mistakes, that's where we are limiting ourselves or not getting what we need to be out of that person or out of ourselves. The geomatics curriculum includes as much lab time as possible, but there is no substitute for industry experience. Completing internships before graduation is highly encouraged, like I said previously in the other video, to acquire proficiency and understand industry norms. There are numerous tricks of this trade, which only learning in a variety of production settings. I cannot tell you how many different little things I know of being in this profession for the past 12 years. I started in 2013 working for my company, and the amount of little tips and tricks that I've learned over those 12 years has been a huge, huge step in trying to help others in this field and how to help them grow in it as well. So again, yeah, like it says here, it's invaluable. It's one of those things that you will learn how to be a effective land surveyor. All right, effective communication and people skills are critical when working on a field crew. So again, making sure your crew is on the same page. You guys are working in sync. You guys are understanding what you guys want to do, how you want to do it, is all very important. So keep that communication open. The general procedures listed will help you finish field labs proficiently. Place completed equipment checkout slips on the counter near the check room door. Record the item number for major equipment and place a check next to the accessories. Do not have numbers. Since crews may complete lab exercises at different times, the door is typically kept slightly open with a wedge doorstop. If your crew returns when the instructor is not available, place the equipment in its proper location. Leave the checkout slip at the center counter. Your instructor will know when your crew is done with the lab, and you will verify when the equipment is returned and the sign off that is checked in. Levels may be carried on a tripod, hold vertically during a field lab for a short distance on flat ground. Total stations should generally be returned to the cases. No instrument should be carried horizontally on the tripod. Set the tripod on the line side outside Owens. Bring the level in case and place the level on the tripod. You can store the case in the equipment room during the lab period. bring the case back outside, return the instrument to the case, and transport back into the equipment room. When the ground is muddy, have a crew member bring paper towels from the restroom and clean the tripod feet up before bringing it into the building. Also clean your shoes as best you can. If the instrument is dropped or damaged, inform us immediately. We have to know about these things. It doesn't matter if you think you're going to get in trouble or any of that junk. We have to make sure that these are running for the next student and make sure we can keep the maintenance of these things. All right. The instructor will assist each field crew during the start of new labs. Once crews are working, if assistance needed, contact the instructor. All right, guys. So I will leave you there. Again, if you have any questions, feel free to reach out. Otherwise, as well as Evan will be of great value to you guys. So make sure you reach out to him. All right. And that's where we'll end this today.